Let us now look at Internet of Things, which is popularly known as IoT. So the topics I'll be covering in this course are microcontrollers to IoT evolution, and what is an IoT and its uses, then IoT architecture overview. This is a kind of a building block by term architecture. Don't be afraid of it. I'll not go into the technical details of it, but I'll be providing you with a building block overview on this architecture. And finally, we'll be closing it with the challenges faced by the current IoT implementation. So let's get started. So the first is, you would have seen this image. You all know, particularly if you're from India, this is electronic voting machine. It has a computer. I mean, it is, once I say computer, don't think about a laptop or a desktop, but it has a processor, computer processor inside it, which is designed to function in a specific way, so that the electronic voting machine will perform the function as what it is designed for. Maybe it has to recognize the key to whom a person votes, and then keep a count of it, and finally when asked it should display the result. So those are the functions, and those functions they might have a program, and program in the sense in this case could be an assembly language. It might not be high level you keep hearing about C or C++. Here it will be a kind of an assembly language. So this is one part of it. It doesn't actually, there is no interface with a computer. There is no interface. You would have heard about this. Can it be hacked? Can some changes be done? Absolutely not, because you cannot connect the EVMs, which is designed by the Indian government. You cannot connect through a Wi-Fi network or through any means. You cannot connect from a laptop or from a mobile device, because it doesn't have any kind of a Wi-Fi capabilities or Bluetooth capabilities. It's kind of a standalone machine. So let's progress further into it. Similarly, you would have seen this in the shops. So this is a digital weighing balance, and this one does have an microcontroller which is designed to get weight and then display it in the digital format. It is because why it need to have a microcontroller, meaning like sometimes you keep a weight pan and that need to be negated, or you want to make a count of equal weight of objects, then it could act as a counting device also. So there are many functions, but generally we see only just a digital weighing machine which is used for weighing alone. So it can do a standalone, it can be a standalone application, or there is some digital weighing balance also has, it can interact with, it can send the weighing signals to the computer, and that is where the protocols comes in. The RS-232C interface, it can send the data to the computer, and then through RS-232, and then you would have seen in the retail shops where they would use the balance and to send a weight, and then they will have a software application software, so that will multiply the quantities. So probably you would have seen vegetables being the weight alone will come into the system which has a software, and the weight will be multiplied by the price, and it displays that price in the screen, or it can send it across to a printer. This is the next level. And if you look at it, all this was there for years, maybe 15-20 years. All this were happening before. Again, 15-20 years back, we didn't have any kind of an internet. Internet came as popularity and really gained significance maybe around year 2000, and as a matter of fact IoT devices gained tractions more from 2010 onwards. So this is a big level architecture about a microcontroller system, which is something like this is a microcontroller system, the weighing balance with the RS-232C connection to the laptop. So if you look at it, these are called sensing devices, maybe a temperature sensor, or you could have a humidity sensor, or in case if you're using a digital weighing balance, there's a weight sensor inside it which will send the signals to the analog to digital converter. Why we require analog to digital converter is that I mean computer can read only zeros and one. So what will happen is the analog signals, I mean, little bit of technicals I'm getting into, may not be hard to understand, but you will have only physical parameters. Say for example, you would have had seen batteries, say small battery like 1.5 volts, maybe a bigger battery, they will say 10 volts battery or 15 volts battery, so something similar. So depending upon the weight of the device, this voltage will vary. Like 1.5 is for probably 1.5 kgs, just an example there, 1.5 kgs, and if it is a 10 kgs, then it will give out 10 volts. So that is the analog signal, and that needs to be converted into a digital signal, and digital signals are fed into the microcontroller device, and so that it will get the data gets displayed in the LED display, or it can send into the printer, and again you will have a program which calculates all the weight and makes it send the data into the display. It controls the entire microcontroller device, and that is through a program, and that resides in the EEPROM device, which is a non-volatile memory, and it could have inputs from a keyboard, and in the recent times, as I said, RS-232C interface, if you really want a PC interfacing, is done. So the point to note is that till this point, it is all there for decades, maybe since 80s and 90s, we had microcontrollers in place. The ideal example is, as I said, the weighing balance or EVM. In case of EVM, you don't have this part. You don't have all this, because there's no measurement. The physical measurement is not happening. It just need to, based on the keypad entry, it needs to compute. It has to store, and it has to compute the results. In case of EVM, this part is absent. That is, the sensors and ADCs are absent. So that's about, and then as I said, you can interface to a PC, nearby PC. You don't need internet for that. There is through the serial connection, you could do that. So this is till up to, I would say, till up to 90s or early 2000, and then internet came. So once internet came into play, and people thought like, why not we use internet? So in that case, you can cover larger geography instead of just restricting to a small room or a small location. If the data can be sent through the internet to the outside world, then probably yes, you can control many things from the outside world. Maybe control from maybe if you are in India and you want to control something from in US, you could do that because the data is sent into the cloud and gets stored in the cloud device, and that's where we started getting into IoT. So what is Internet of Things? So use internet to interact with any device. Interact meaning it could be kind of a communication which could happen back and forth. So it could be the it could be a home, in case of home retail application, could be switch on or switch off the heater, television. And why do we require that? Suppose you're outside your home, maybe in another 10 minutes you're reaching home, and you want to switch on the heater or the aircon, so that by the time you reach home, you have set temperature in the aircon, or your water geyser is switched on so that you get a hot water. So you don't need to, otherwise you need to reach home and then you switch on the heater. It's going to take maybe 10 minutes before the water gets hot up or heated up. So you want to have whatever the time you want to utilize it effectively, then you can go for an IoT based devices. So heater, and I mean, in the recent times you also hear about cars. Cars is, self-driven cars or the driverless cars is common these days. So they are building it, and that is where the technology of machine learning being used in autonomous cars. I'll not go into the details. Then if we get into that, it will be more technical. And there could be industrial applications like temperature, pressure, weight, all need to be monitored, and corrective actions needs to happen. So use of internet to interact with any devices. So that is what is all about Internet of Things. So from Gartner, if you look at the definition, it's the network of physical objects that contain embedded technology to communicate and interact with internal states or the external environment. Embedded technology, the word embedded meaning, You have a hardware is something, and you have software also built into it. So that's where it is called embedded into it. You will not be, for a third person, you will not be able to visualize it, because it'll gel with each other. Hardware and software will be in a device, I mean in a memory card, so you'll not be visible to the outside world. So that's the embedded technology concept. So from a definition perspective, as I said, network of physical object that contains embedded technology to communicate, interact with their internal states or external environment. So that's the definition part as of IoT. We will get into the scope, the IoT scope, and where it will be used shortly. Let's now look at the architecture on Internet of Things. More than the architecture, it's a kind of a block diagram where you can easily identify what are the components involved in IoT. So there are four main components in IoT. The first one is the sensor meaning any physical parameters, be it temperature, be it pressure, or even in some cases you might have a camera to get the image. So these days the sensors can be, earlier days I'm talking about 20 years back, the sensors were analog sensors. And again, that's a technical term. The analog is something like it will give a continuous signal in millivolts, whereas these days there are sensors which can give digital signals. Digital, by that it's zeros and ones, which can be readily processed by the computers or IoT devices. If it is sensor is an analog sensor, then you need to have analog to digital converter in between, and then A to D converter needs to be there, which can send signal to the IoT device. This is a common temperature sensor which is used with the IoT device. So just for a block diagram, and from the sensor, and again, so this is a digital sensor, and digital sensor will send out ones and zeros, which will be then acquired by the IoT device. So this is an IoT device, is commonly used IoT device. One is Arduino Uno, and then this one is Node MCU, and this one is Raspberry Pi. There are so many other IoT device. IoT device is what is an evolving field. Every year there is a new board which comes out, just like the laptop computers. It keeps evolving and keeps better and better. So that's where it all started from. Of course, Arduino Uno was started in 2005, but Raspberry Pi was in 2012, if I remember correctly. A Node MCU, it's a small, just less than a visiting card size. It is started in 2017-18. So these two, that is Raspberry Pi and Node MCU, there's a lot of, each year a better board is coming up, just like laptop, and that is where the adoption of IoT is growing over the time. And next maybe another 4 or 5 years, you'll find IoT devices in almost every walk of life. So data is sent in from the sensors to IoT device, and then from the IoT device has programming. It can support Python, any other C, C++ and all. Earlier days it was assembly language, and now you can use Python programming language, and through the internet, and each one it has Wi-Fi capability, so that means it can send data. And the commonly used protocol is HTTP, and then a protocol called MQTT is there, and of course the LoRaWAN is for the wide area network, narrowband wide area network. We'll get into that little bit details later. So these are the protocol, but again, if you get into the protocol, it is too technical and it will be difficult for a non-technical person to understand. So it uses the protocol meaning handshake needs to happen, through which the data can be sent across from the IoT device using Wi-Fi through the internet gateway to the cloud system, where cloud, again, you have a computer which is going to receive the data. There are freeware cloud system like ThinkSpeak and My Devices is widely used for data capture for IoT device. Though there are others like even every other cloud providers like Amazon, Google, then you have Oracle, all support IoT device, but ThinkSpeak and My Devices are extensively or exclusively are designed for IoT device. That's where seems to be much better than the already well established players, cloud players like the Googles or Microsoft and all, because they offer other services along with the IoT services, whereas these two are predominantly and almost exclusively for the IoT purpose. So that's where as of now, they tend to stand apart from compared to other regular cloud players. And then based on the temperature signal, so you want to control something, you will need to have a relay unit. Relay unit is something like, if you want the AC to be switched on based on the temperature, then you need to have a relay unit. So it is connected to the port, and again, that's a technical part. So port in the IoT device which will trigger that switch. Relay is some kind of a switch on off. Manually you'll be switching on or switching off light or fan. The actuator and relay is an automated switch. Based on the condition, it will switch on or switch off the process. Process in the sense, it will, if it is connected to the heater, based on the temperature settings, it will maybe switch on the heater or switch off the heater. Similarly, aircon or whatever you can do with many process, you need to use the relay unit. So in a way, this is how the architecture is there. You have sensor unit, you have the IoT device, and then you need to be knowledgeable on the programming to effectively communicate with the sensors and IoT devices, and use the communication protocols to send the data to the cloud. And then you need to use, if you want to make it a control system, you need to have actuator or relay unit in place. So that's about an overview about the IoT architecture. Let's now look at an overview of the devices, IoT devices. The reason is, about a decade back, if you say IoT devices, it was not there at all, virtually was not there at all. Of course, Arduino was there, Arduino board called Arduino Uno, but it was more of a microcontroller based board. It was right from 2012 when Raspberry was introduced and Internet of Things got caught up. So it's about 5 to 7 years is what I would say that IoT has caught up. The reason being, it's a small IoT board which came into the market, and actually Raspberry Pi drove this because it was just costing about 35 USD, which is about, in Indian rupee, if you compare, it should be about 2,000 to 3,000 rupees, and that is where IoT start booming. Otherwise, yes, internet was there. Cloud, yes, cloud also came at that point of time, 2012, 2013. But yeah, cloud is nothing but it's all computers which is lying in some data center. So that is called cloud. Ideally, even emails you can consider as a cloud. So cloud was there, internet was there, sensors were there. What was not there are the IoT devices which gained popularity beyond 2012, starting with Raspberry Pi. So if you look at, as I said, Raspberry, this is the Raspberry Pi image. I mean, sorry, this is Arduino Uno image. This is Raspberry Pi. This is the latest version. You have now Pi 4 is there. So Pi 1 is what was introduced in 2012, which was actually Raspberry Pi, for information. It was for just to have knowledge of or as a hobby kit. It was introduced. It is still called a microcomputer because you can connect to a with the Raspberry Pi, you can connect to a monitor, you can connect to a keyboard. Since it has a Linux operating system, it can work as a just as your computer, because you can connect to a computer, keyboard, you can connect to a display unit. So that means it can work, and with a Linux operating system, it can work as a computer. But yeah, the capabilities will be much slower. It will not be as efficient as a laptop. That's the main difference. But the advantage is that you also have these are the pins. These are called the ports. This is where you connect it to the either the sensors or actuators. These are the IO pins. You'll have the IO pins in all the IoT devices. Even here, it's at the other side, the bottom side. You have the IO pins, or it is called the port. So this is of course the node MCU, and this is symbol which is generally represents the Wi-Fi connectivity. So Arduino Uno doesn't have a Wi-Fi connectivity. You need to have an external board connected to it. So Arduino Uno, Node MCU, and 32 is what is the latest. Raspberry Pi 4 is the latest. And built-in Wi-Fi connectivity is available for Node MCU and Raspberry Pi as well. So this is at a details of the board. You have a GPIO pin. It is called the IO pin. You have the USB port. You have the LAN cable. You have the audio socket to connect the audio. HDMI, this is where you connect it to the your monitor, to the HDMI port. You can connect it to the USB port. You can have an USB keyboard. It has the onboard Wi-Fi. It has the micro SD slot wherein you have the OS. You can create a Raspberry OS and insert it. So which means it can boot on its own on power on. So it's a kind of a microcomputer board plus the GPIO pins, because in the computer you will not have this GPIO pin. That is where you cannot connect the sensors or your actuators, that is a switch. If you recollect it correctly, relays a switch, you cannot connect it with the computer, whereas with the GPI open, you can connect with them. And because Wi-Fi is there, you can connect it to the cloud as well. So in a way, it will be a complete Internet of Things board. So this, you can call it as our heart of the computer. It is also the brain of the computer, because that is where it has the memory capabilities. It has you can have the programming which can control acquiring the data from the sensors. You can control, you can send signals to the relay unit to switch on or switch off the heater, and so on and so forth. And this is a bit of into technical, which gives the processor, what is the memory, and if you look at the memory size, that's where you can really not compare it with any kind of a computer, because the memory size is 1 GB RAM. If you look at laptop and all, it's almost 8 to 10 times more now. So it's just 1 GB RAM, and the others are even worse. The Node MCU, and it's all in KBs. So the IO pins, that is what is important. And analog pins. Arduino Uno has the analog pin, which means you can send in the signals in millivolts. It'll convert into digital signals, so that it can the sensor input can be made into digital, so that it can do the processing. So Internet Connect is not there in Arduino, whereas all this has that. Programming with what you can program, it's all there. Raspberry Pi, it is just like a computer. You can even have Python, you can have C++, whatever you wish. You can, all that you need to do is you can download and install. Only thing is, Raspberry Pi or BeagleBone works in the Linux operating system. There are some, like if you look at Windows, in fact Microsoft has its own version of for specifically for IoT board. It has its own version of the operating system, but it has not gained that much traction when compared to the Linux system, because it is always felt like Microsoft is a little heavy, whereas Linux is much it is very sleek or slim, you can say, meaning it doesn't occupy that much memory, whereas all the Microsoft product occupies memory. That's where it is going to be a challenge. If you look at the pricing, it's so cheap, and this is where the Node MCU has caught up very fast, just about $5 with a Wi-Fi connectivity. The Raspberry Pi is the costliest, it's about $35. So that's a quick comparison on the IoT boards. So as I said, the IoT boards, that is where if you look at IoT as such, it is it's evolving. It's evolved over time, but the start point is always, I would say, it gained popularity because of Raspberry Pi, which was introduced in around 2012 period, and now more and more boards. There is also called BeagleBone, there is Orange Pi, Banana Pi. I don't know why they keep fruit name for it, but that is how it is. Raspberry Pi is there, Banana Pi is there, Orange Pi, and each are different, of course, altogether made by different companies. And again, the prerequisite, if you look at, if you want to technically get into it, you need to be strong on Python. Whereas in the olden days in the say 2 decades back, when they were using microcontrollers, you need to be strong on the assembly language part of it, which is a kind of a low-level programming. Whereas now you can be a high-level, you can have high-level programming knowledge of Python. You can use Python, C or C++. So that's about the IoT devices. Let's quickly look at the challenges in IoT. But that is what is of course, the future of IoT as well, the future direction in which we would be moving in the future. So the challenges, if you look at it, the IoT device reliability. As I said, it's all started with the Raspberry Pi, the IoT movement or the adoption, I would say. But in fact, the Raspberry Pi was more developed as an hobby kit. Though it is reliable these days, it's almost more than 8 years, and it was introduced as Raspberry Pi 1, and now we are in Raspberry Pi 4, which is higher compute capabilities, better RAM, better stability, and so on and so forth. But still, it is evolving. So that is where the reliability is one factor. I think over a period of time you will be getting it there. Cost and compatibility. As of now, there is a technology which is more on the network side. One is the broadband, and another one is narrowband. We'll get into a slide, next slide, which will be much more easy to understand. Low power wide area network is what is LoRaWAN, and cybersecurity is always evolving field. That is, of course, one of the challenges in the IoT as well. So as far as the broadband and narrowband, so LoRa is a low power wide area network standard. That is what is the LoRaWAN. The reason is low power, meaning computers, if you look at it's comparatively, you need to have better power capabilities. But in a remote area, say for example in a farm or somewhere, you might not have 24/7 electricity, or you might not have a UPS facility. So in that case, it should be operated on through a battery, small cell battery. So that is where this technology is gaining momentum, the low power wide area network. And again, you might not have that is one is the power area, the other one is of course the network. You might not have a Wi-Fi connectivity. Even if it is Wi-Fi connectivity, it is not necessary, because all these IoT devices or your sensors just going to send out a byte of information. So say for example, if it needs to send a temperature measurement of 30 degrees, so it's just what to say about maybe two byte information. 8 bits is 1 byte, so 3 bytes of information. Once in few seconds it needs to send, maybe, or even in minutes it might send about 3-4 bytes. So the data is very small, and you don't need a broadband there. So that is where you need to have these devices needs to work as on the narrowband. And again, that technology in the developed countries, it's there. India, in the last 2 years, they are saying that like Vodafone and Airtel are saying we are going to come out with the narrowband technology. But due to some reason, maybe there is no adoption at all, no demand at all, they are not yet come out with it. So that is a kind of now has become a particularly for any kind of a remote sensing. Ideal example, I will say, like currently we keep hearing that the fishermen going out in high sea get lost because they don't have any connectivity. The mobile connection is not there, and so on and so forth. But once you have this technology, that is narrowband, so that means it's just going to send a byte of information to a Wi-Fi station, like it's going to be within 10 meters Wi-Fi station, whereas the narrowband station could be even with kilometers, maybe about 10 kilometers. Even the station is narrowband station is 10 kilometers away. Just a byte of information it can send across to the narrowband, because just a byte of information, you don't need megabytes of information to be sent over there. So that is where this technology is catching up. And the current scenario, we are using the Wi-Fi used, local area, high bandwidth, power, as I said, needs to be available 24/7. This is all okay in an IoT application. Like if it is for a hospital, it's all okay, it's fine, because hospital, if it is going to be in the city, in a building, power supply shouldn't be a problem. The Wi-Fi or the broadband connectivity is not a problem, so no issues. Just along with a computer, you can use it. But when in case of a sensors, particularly if it is a parking lot which is running for maybe few acres in parking lot, or as I said, fisherman who is in the deep sea, just a byte of information needs to be sent, or it's kind of an industrial atmosphere where it is you might not have Wi-Fi connectivity there. You need to have just the narrowband connectivity, and then you need to use this technology, that is the LoRaWAN. So what would be a scenario? Whatever we discuss, if you want a sensor device to receive signal from a remote location, that is where this LoRaWAN comes into picture. So Wi-Fi, you have high bandwidth, but range is small. You have maybe in meters, but bandwidth is more. So mobile is intermediate, range is higher, broadband is still less. And the last one, if you look at it, the LoRaWAN, range is higher, bandwidth might be very low, because just going to be byte of information. And that is where these adoptions will be higher in the other areas like farming, or maybe remote sensing. That's where we could see an exponential growth in it. Suppose if you want to track your vehicle, where it is, anywhere it travels, still now, as of now, they use the mobile internet. But even you don't need a mobile internet once you have the narrowband. Anywhere the car, your vehicle is there, you just need to where it is, that location data needs to be just sent across. So the adaptability, and again the cost is going to be less because just a byte of information. So you don't need to have spend thousands of rupees just for a month just for connectivity. It might be in few hundreds. Then the adaptability, particularly for IoT, is going to grow exponentially with a narrowband in the future. So the range is higher, data bandwidth is going to be less in case of the LoRaWAN. So communication, as I said, communication with fishing boats, car parking, remote sensing in agriculture, measuring the soil parameters, whether you have enough water or there, because agriculture tea estate where you might not have the broadband connectivity at all, then you need to have this kind of a narrowband facility. And maybe in the future, that is where that's a challenge as of now, but that is where you have the future. And the technology is already there. It's there in almost all the developed countries. India, over the period of time, we will have it soon. So that's about IoT. We have seen about the architecture as such. We see initially we started about the evolution, and then we saw about the IoT architecture and the IoT devices, and finally we ended up looking at the challenges. And once the challenges are broken, and that's where the adoption of IoT is going to grow exponentially. Thank you.